Hi student, welcome back to Haber cycle. Since we cannot determine lattice energy experimentally, we're going to explore how Haber cycle help to determine the lattice energy of ionic compound. I will guide you how to construct Haber cycle. In constructing Haber cycle, we are going to apply Hess law. Let me share you some hints. We are going to construct Haber cycle by including standard enthalpy formation and all enthalpy required to make gaseous ion from elements. There are two ways to draw Haber cycle. One is Haber cycle in form of energy cycle diagram. Two is Haber cycle in form of energy level diagram. Let's try to construct Haber cycle for sodium chloride and determine its lattice energy. The value of enthalpies are given as shown on the slide. I will show you the Haber cycle of sodium chloride in form of energy cycle diagram. First of all, you have to write the thermochemical equation for all enthalpies given on the previous slide. Thermochemical equation for formation of sodium chloride. Thermochemical equation for sublimation of sodium. Thermochemical equation for ionization energy of sodium. Thermochemical equation for atomization of chlorine. Thermochemical equation for affinity electron of chlorine, and thermochemical equation for lattice energy of sodium chloride, which is we don't know the value. All thermochemical equations we wrote just now are very important in step number 2, which is to construct Haber cycle. We start drawing the Haber cycle by writing thermochemical equation of standard enthalpy of formation first. It's better to write on the top of the cycle, but it is not compulsory to put it on the top. Atomize the element, then ionize the atom until it forms gaseous ion. For example, atomize sodium solid to form sodium gas, then ionize sodium gas to form sodium ion, then sodium done. We repeat the same step to chlorine molecule. Start by atomize chlorine molecule and next convert the chlorine atom to chloride ion. Plus both sodium ion and chloride ion to form thermochemical equation for lattice energy of sodium chloride. Each of thermochemical equation, you must write the value of enthalpy and phase its indices. From the cycle, there are two routes to form sodium chloride. Route number 1 is via delta H1. Route number 2 is the sum of delta H2, delta H3, delta H4, delta H5, and delta H6. By applying Hess law, delta H1 equal to delta H2 plus delta H3 plus delta H4 plus delta H5 and delta H6. By doing this, you are able to determine the lattice energy of sodium chloride. I hope you get the idea how to construct Haber cycle in form of energy cycle diagram. Now, let's try to construct Haber cycle of sodium chloride in form of energy level diagram. To draw energy level diagram, we apply the same step as we did to draw energy cycle diagram. First, write the thermochemical equation of standard enthalpy formation of sodium chloride. Next step is atomize the element and then ionize it until it forms gaseous ion. In energy level diagram, there are two types of arrows direction. The upward arrow represents positive enthalpy and downward arrow represents negative enthalpy. Next is write the equation for atomization of sodium, then atomization of chlorine. Ionize sodium gas, then ionize chlorine atom. The enthalpy arrow for affinity electron of chlorine is pointing down because this enthalpy have negative value, same as lattice energy. And the Born-Haber cycle in form of energy level diagram is formed. Finally, find the value of lattice energy by applying Hess's law. Let's study the Born-Haber cycle for calcium fluoride. At the top, we write the thermochemical equation for enthalpy formation of calcium fluoride solid. We work from the most left, calcium metal. By applying the hint I give on the previous example, we will ionize calcium until it forms calcium 2+ gas. Then, we will ionize fluorine. Look at the formula of calcium fluoride. From the formula, 2 mole of fluoride ion are required. So, in atomization of fluorine molecule, we need 2 mole of fluorine atom. Therefore, enthalpy atomization of fluorine will be multiplied by 2. Seems that we target to get 2 mole of fluoride ion, 2 mole of fluorine atom will be involved in electron affinity. So, for electron affinity, we need to be multiplied by 2 also. Join the calcium 2+ and fluoride ion to get lattice energy. So student, when you want to ionize the element from the enthalpy of formation equation, you need to study the formula of ionic compound. How many cation and anion are required to form the compound. Lastly, in order to determine the lattice energy, we're going to apply Hess's law. Watch again this video to gain better understanding of constructing Born-Haber cycle. Until we meet again, thank you.